Welcome back. This is Module 2, Week 1. In this lecture, we will discuss national testing and why we should be using it to drive evidence-based practice and explore what NAPLAN is actually testing. We'll also investigate ways we can help students prepare for NAPLAN. Many primary schools in Australia spend a great deal of time focusing on the annual NAPLAN test, preparing students in ways that don't always reflect good practice. Some schools spend significant amounts of time running through practice tests to get students used to the format of the test and to test conditions. I was once in a conference session where an academic from another university was encouraging teachers to set NAPLAN-style questions for kindergarten children. Although NAPLAN is now evolving into an online and more flexible environment, the practice in some schools and classrooms understandably leads to much student anxiety and quite often teacher anxiety. As we know, test anxiety can lead to results that don't reflect the students' true abilities. We also know that teachers are put under an immense pressure for their students to perform well in NAPLAN as they feel the outcomes reflect on their abilities as a teacher. Despite the negative aspects and practices that arise from looming NAPLAN tests, we need to focus on the potential benefits of NAPLAN. Forget the league tables and the comparisons that members of the community may make. Remember why we are here: to improve learning outcomes for our students. How can we take advantage of national testing and use the evidence gathered to improve teaching and learning in mathematics? Before we address this, let's talk about what NAPLAN is actually testing. One of this week's readings is a paper written by Thelma Persaud, who is a highly respected Australian mathematics educator. Thelma discusses numeracy as the focus of national testing in Australia. Before we look at what she says in relation to the testing, it's important that we first clarify the difference between mathematics and numeracy. When we talk about numeracy, we are referring to the ability to use and apply mathematics to meet day-to-day demands. Therefore, mathematics provides us with a set of tools, and numeracy is the way we use those tools at home, school, work, and in our communities. We can also consider mathematics and numeracy in relation to the way our curriculum is structured. In the Australian curriculum, we have the proficiencies and we have the content strands. Likewise, in the New South Wales curriculum, we have working mathematically and the content strands. The proficiencies and working mathematically components are the numeracy aspect, where the content strands deal with the mathematics. Numeracy is a capability. A person is either numerate or not. So how do we assess numeracy? Assessing processes and decision-making about when, where, why, and how to use mathematics is problematic and impossible to do on a large scale. In fact, Persaud states it's rare for teachers to assess numeracy, and more often than not, teachers focus on aspects of numerate behaviour, particularly students' abilities to use and apply selected methods. This usually results in assessing narrow forms of mathematics or a mathematical skill as opposed to an application of mathematics. Typical test questions are so narrow that they remove much of the choice for students, leading to a test for recall rather than reasoning. The National Assessment Program Literacy and Numeracy Tests, or NAPLAN, attempts to assess numeracy, as Persaud states, to some extent. It's not possible to have a perfect assessment of numeracy. The interesting point Persaud makes about NAPLAN is that there is a clear intention for the questions to be non-typical. That is, they are novel questions that hopefully students have not been exposed to before. Let's think about this. We often hear teachers complain about the style of NAPLAN questions, yet they still feel students have to learn NAPLAN style to solve NAPLAN style problems. We've all seen the NAPLAN style test books that parents can buy from newsagents and bookstores. Rather than attempting to teach a test style, it makes more sense to teach students to be good problem solvers, just as in the Hooray for Differndoofer Day picture book. Persaud suggests using a problem-solving framework, such as clarify, choose, use, interpret, and communicate, to assist students in becoming successful problem solvers and to assist them in addressing the significant language demands of national testing. My preferred framework is Polyer's four-step approach, which I will briefly explain. George Polya, a Hungarian mathematician who lived from 1887 to 1985, is known as the father of problem solving. In 1945, he published a seminal work entitled How to Solve It, in which he outlined a framework for problem solving that is still current today. The framework is a useful tool for students of all ages that promotes effective problem solving through the use of 4 steps. Step 1 is understand the problem. During this step, encourage students to understand what the problem is asking them to find or show. Have students paraphrase the problem and perhaps draw a diagram or picture to help them understand the problem. Is there enough information to find a solution, or is there too much information? Do students understand all of the words in the problem? Step 2 is devise a plan. This is where students draw from their toolbox of strategies and plan how they are going to address the problem. Will they use a guess and check approach or look for a pattern? Perhaps they will work backwards or solve a simpler problem. Step 3, carry out the plan, is where the work gets done. And sometimes this is quicker than steps 1 and 2. Always encourage students to record all of their work, as this will assist in the reflection phase. Finally, in step 3, review, extend, students reflect on what worked and what didn't. How do we know if the answer is correct? Was there an easier way to solve the problem? How could we extend this problem to explore further? Using a framework such as this assists students in developing problem-solving habits and strategies that will be very helpful in NAPLAN. To assist students in preparing for NAPLAN and for general numeracy, it's also important to develop estimation skills. Many of the NAPLAN questions are multiple choice and often require estimation skills as well as efficient problem-solving strategies. Of course, students need to have deep knowledge of mathematical concepts to be able to estimate effectively, and this is something that we often forget to work on in mathematics lessons, even though Northcote and McIntosh found that more than 85% of day-to-day calculations require estimation and not a precise answer. All of these strategies to help students be successful with NAPLAN are important. It's also important to understand some of the impacts of NAPLAN, as discussed in the paper by Harris et al., who in 2013 prepared a submission to Australia's Senate Committee inquiry into the effectiveness of NAPLAN. The authors outline a range of limitations associated with NAPLAN, including its limited coverage of content and skills and the time allocated for sitting the test. They stress the need for other sources of evidence, including data gathered by teachers to inform practices and learning outcomes. In the next 2 weeks of this module, we will look more closely at what Harris et al. Say, and we will look at ways we can use NAPLAN data along with the range of evidence we collect as part of our everyday practice to plan learning. In the meantime, please contribute to this week's discussion board, where you will be writing about negative perceptions of NAPLAN testing and ways to address them with your colleagues.